Imagine entering the chemistry practical hall and the titration question drops exactly like this. Would you panic or confidently calculate the answers in minutes? In this video lesson, I will show you the complete step-by-step titration practical involving tetrasulfate 6 acid and sodium hydroxide. I will also teach you how to balance neutralization reaction involving tetrasulfate 6 acid and sodium hydroxide. And I'll also explain all the possible calculations that you are likely to see in the 2026 WAEC chemistry practical examination. So if you want an A1 in this chemistry practical examination, make sure you watch this video lesson till the end. You're welcome back to Organotope Chem Clinic, where chemistry becomes simple, practical, and exam focused. WAEC 2026 chemistry practical titration experiment question states that A is a solution of 5.0 gram per 500 cm cube of H₂SO₄. B is a solution of 1.0 gram per 250 cm cube of XOH. So in this question, the identity of the base is unknown, and the procedure for this titration are stated right here. Pipette 25.0 cm cube of solution B, which is the base, into a conical flask. Add 2 to 3 drops of methyl orange indicator and titrate against solution A, which is the H₂SO₄, from a burette to an endpoint. So the endpoint expected for this titration is orange or red endpoints. As I've explained in my previous video lesson, you can check the link in the description below. The procedure given right here were followed step by step, and we're able to obtain the volume of acid used for our titration. So I'm going to give the volume of acid used based on the titration conducted right here. We have, for the rough titre, we got 13.00. Remember, you are expected to record the volume of acid used to 2 decimal places. And we started with an initial of 0.00. So the final volume is 13.00 in this case. Okay? Now we conducted the first titration and we have 12.30 for the volume of acid used. We also started from 0 meniscus, so the initial is 0.00 and the final volume of acid used for the first titre is 12.30. Also for our second titration, we started from 0 meniscus, that's 0.00, and we have the volume of acid used as 12.20. Therefore, the final volume of acid used is 12.20 plus 0.00. We have 12.20. Okay? Then for the last titration, we continued from the 12.20 meniscus. So the initial will be 12.20, and the volume of acid used in this third titration is 12.20. So when we have 12.20 plus the initial 12.20, we are going to have 24.40. Make sense? Can we determine the average volume of acid used in this titration, which is the same thing as the average titre value? For this titration, we are expected to ignore the rough titre, and we are going to consider the first, second, and third titre because we have concordant value in the 3 titration. The values are said to be concordant because the range between the values gotten for the volume of acid used is plus or minus 0.1. So we have 12.30, 12.20, and 12.20. That's plus or minus 0.1. So the values are said to be what? Concordant. So we'll pick the concordant value to determine the average volume of acid used. So we have the first titre is 12.30 plus 12.20 plus 12.20. So we are going to divide it by 3 to get the average. Okay? So when we add this together, we are going to have 36.70 divided by 3. When you press your calculator, you're going to have approximately 12.23 cm cube. So we expect to record to 2 decimal places, and the correct unit for the average volume of acid used is cm cube. So while tabulating, do not omit the unit of the volume of acid used, which is cm cube, in each column. Moving on, can we write a balanced chemical equation for this titration? we're given an unbalanced chemical equation, so there is need for balancing. We have H₂SO₄ plus XOH going to X₂SO₄ plus H₂O. That's water. So there is need for us to balance this equation. Can we check the number of atoms of individual elements on both sides of the equation, that is the reactant and the product side? We can observe on the product side we have 2 atoms of X. So there is need for us to introduce 2 as the coefficient of XOH, and the hydrogen atom on the reactant side, we have 2 atoms here plus 2 times 1, that's 2, making 4 atoms of hydrogen on the reactant side, and we are just having 2 atoms of hydrogen on the product side. So we need to introduce a coefficient of 2 to water to balance the atom of hydrogen. Then sulfur, we have 1 atom of sulfur on the reactant side, 1 atom of sulfur on the product side. 4 atoms of oxygen right here plus 2 atoms of oxygen, making 6 atoms of oxygen on the reactant side. So there is need for us to balance it with what we have on the product side. So 4 plus 2 times 1, that's 2 plus 4, that's 6 atoms of oxygen on the product side. So we now have a balanced neutralization reaction between the tetraoxosulfate 6 acid and XOH. So can we indicate the mole ratio of acid to base? We have 1 mole of acid reacted with 2 moles of the base in this titrimetric analysis. Moving on, can we consider the next question? From your results and the information provided, calculate the concentration of A in mole per dm cube. In my previous video lesson, I explained how to determine the concentration in mole per dm cube and also how to determine the concentration in gram per dm cube. Concentration in gram per dm cube is mass concentration, while the concentration in mole per dm cube is called molar concentration or molarity. So you can check the link in the description below for the video lesson on molarity and mass concentration. So moving on, can we now determine the molar concentration of A? From the information given for the solution A, we have 5.0 gram per 500 cm cube. We can determine the mass concentration of H₂SO₄. So we convert the volume from cm cube to dm cube by doing what? That's right, by dividing by 1000. So we have V equals 500 divided by 1000, which will give 0.5 dm cube. So we've been able to convert from cm cube to dm cube. So how do we determine the mass concentration? Mass concentration of H₂SO₄ is given by, that's concentration in gram per dm cube equals m over v. Okay, so the mass given right here is 5 and the volume in dm cube is 0.5. So the mass concentration is 10 gram per dm cube. Okay, so that's the mass concentration of H₂SO₄ for this titration. Can we now determine the molar concentration of H₂SO₄, that is solution A? We can determine the molar concentration of solution A, which is H₂SO₄, by using this formula. Concentration in mole per dm cube equals concentration in gram per dm cube divided by molar mass. Okay, so can we get the molar mass of H₂SO₄? So the molar mass of H₂SO₄, what's the atomic mass of hydrogen? Hydrogen is 1 times 2 plus the atomic mass of sulfur is 32 times 1. We have 1 atom of sulfur. The atomic mass of oxygen is 16 times 4. So by the time we sum this up, it will give 98 gram per mole. So that's the molar mass of H₂SO₄. So we can determine the molar concentration. We have concentration in mole per dm cube equals the mass concentration of H₂SO₄ is 10. We have 10 over the molar mass of H₂SO₄ is 98. Therefore, the concentration of H₂SO₄ in this titration is, can we get that? 10 divided by 98. We have 0.102 mole per dm cube. This implies that we have 0.102 mole of H₂SO₄ in 1 dm cube of the solution. Or I can equally say we have 0.102 mole in 1000 cm cube of the solution. Alright, can we determine the concentration of B in mole per dm cube? Since the concentration of the acid is known, the acid is considered the standard solution, that is solution of known concentration. So we can now determine the concentration of B in mole per dm cube. We can use this general expression for the concentration of B in mole per dm cube. We have the expression Ca Va over Cb Vb equals Na over Nb. Okay, for O-level exam, this formula is valid, but for advanced level exam, we don't use this formula CaVa over CbVb. Okay, now can we make C be the subject of formula? We have Cb equals Ca Va Nb, that's when you cross multiply, divided by Vb Na. Okay, so we have Cb equals, the Ca is 0.102 times the Va, that's the volume of acid consumed, which is 12.23 times the number of mole of base is 2, divided by the volume of base is 25. That's the volume of base pipetted is 25. Okay, and the number of mole of acid in the balanced equation is 1, so times 1. When we press our calculator, we are going to have Cb equals 2.49 divided by 25. Okay, so the final answer is 0.0996 mole per dm cube of XOH. Remember that the identity of the base is unknown, so it is denoted as XOH. Make sense? Alright, can we consider the next question? We have to determine the molar mass of XOH. Recall that the concentration in mole per dm cube equals concentration in gram per dm cube divided by molar mass. So when we make the molar mass the subject of the equation here, we are going to have molar mass equals, that's concentration in gram per dm cube divided by concentration in mole per dm cube. Okay, so the ratio of the concentration in gram per dm cube to concentration in mole per dm cube is the molar mass of the XOH that we are considering. Now, can we determine the mass concentration of the base? From the information given right here, we have 1.0 gram per 250 cm cube of XOH, which implies we can convert this to dm cube by dividing by 1000. So we have V equals 250 divided by 1000. So we are going to have 0.25 dm cube of XOH. Okay, so since we know the volume in dm cube, we can now find the mass concentration. So concentration in gram per dm cube of XOH equals mass over what? Volume. So what is the mass? We're having 1.0 gram, 1.0 divided by, and the volume is what? 0.25. 0.25. So when you press your calculator, what do we have? That's right, we have 4 gram per dm cube of XOH. So this is the mass concentration of XOH. We have 4 grams in 1 dm cube of solution. Make sense? Since the mass concentration of XOH is known, we can determine the molar mass of the compound. Therefore, we are going to have molar mass equals mass concentration is 4 grams per dm cube divided by what is the molar concentration of XOH? That's right, we're having 0.0996, okay? 0.0996. So when you press your calculator, what's the final answer? We have 40.160. So we can have it as 40.16, okay? Since it was stated in the question that we should find the molar mass, we need to state the units, which is what? Gram per mole. Make sense? Can we consider the next question? We're told to find the relative atomic mass of X in the formula XOH. XOH equals 40.16. That is the molar mass of XOH. Atom X is unknown, but oxygen has the atomic mass of 16. So we have plus 16. And hydrogen has the atomic mass of 1. So we have plus 1. Okay? So when we have 16 plus 1 equals 40.16. Okay? Can we make X the subject of the equation? 16 plus 1 is 17. Take it to the other side of the equation. We have 40.16 minus 17. So the final answer is 23.16. So the relative atomic mass of X in the formula XOH is 23.16. So you may be asked to express the relative atomic mass to the nearest whole number. To the nearest whole number, we have approximately 23 as the relative atomic mass of element X. So you may be asked to identify element X using the relative atomic mass. So which element in the periodic table has the atomic mass 23? That's right, sodium. That is sodium, right? We have sodium with symbol what? Na. Okay, that's the chemical symbol for sodium. We've been able to identify the element X using the relative atomic mass 23. Make sense? Can we consider the last question on our titration calculation? We have the mass of H₂SO₄ in 20 cm cube of solution. We have to calculate the mass of H₂SO₄ in 20 cm cube of solution. What are we expected to do in order to determine this? We can see from the information given that we have 5.0 gram in 500 cm cube. So you're going to write since 500 cm cube of solution contains 5.0 gram. 0.0 gram. What will 20 cm cube contain? 20 cm cube of solution will contain X, okay, gram. Can we make X the subject of the equation? We are going to cross multiply. We have 20 times 5 divided by 500. Okay, so when you press your calculator, you're going to have 0.2 gram of H₂SO₄ is contained in 20 cm cube of solution. Make sense? What concentration did you get for H₂Y in the comprehension question? If this chemistry practical explanation helped you, then you are already ahead for the WAEC 2026 chemistry practical examination. Don't forget to subscribe to Organotope Chem Clinic for more chemistry practical tutorials, calculation tricks, and exam-focused lessons. And don't forget to share this video lesson with every science student preparing for WAEC, NECO, and A-Level Chemistry Practical Examination. Watch out for my next video lesson on salt analysis and gas test.